I've reported on James Webb Space Telescope many times and talked to a lot of the people behind the scenes who helped originate the idea for the mission, helped design the optics and technology for the mission. And now I bring you a conversation with a person who was instrumental in helping to get that mission into space. My guest today is Dr. Thomas Zurbuchen. He was the head of the science directorate at NASA from 2016 to 2022. And so he oversaw dozens of missions, both existing missions as well as new missions, and has just 1,000 stories. We didn't have time to go through all of those stories, but we were able to cover some really interesting and poignant memories about that. But he has a new job where he is the professor and director of ETH Zurich Space. And so he's taking those lessons learned at NASA and helping to extend those to a more worldwide international audience, new students who are attempting to sort of begin their careers in space and astronomy, space exploration, commercial space, things like that. So this is an absolutely fascinating conversation with somebody who is devoted to space and astronomy, and I think has some really interesting and unique insights that when you hear him talk and you hear the missions that he was associated with and some of the really interesting and clever ideas that happened, like the Ingenuity helicopter, the Europa Clipper, the work done by Perseverance, and then some of the missions that are coming in the future, I think you'll understand how his sort of creativity and his methods sort of infuse the DNA of NASA during his time there leading the science missions. So enjoy this conversation with Thomas Zurbuchen. Thomas, take me back to being at the launch site in French Guiana, watching James Webb, knowing it's on top of that rocket, and sort of thinking about so much time and energy that went into building that telescope and hoping for a safe launch.
Yeah. First of all, it's now one of my favorite days. Just kind of I will celebrate my whole life as we go and have Christmas, not just because of my children and grown-ups celebrate Christmas of one religion and so forth, but because of that moment. Of course, what had happened is really remarkable. We were supposed to launch the day before. It had slipped actually a while because of issues that we had encountered on the way, which is not uncommon for this telescope. I felt we found a number of issues, but I remember the day before, basically on a French helicopter flying and basically seeing the rocket standing there. And of course, if you look at it, it's a rocket that's costs of the order 100 million euros, whatever, order of magnitude, and has a payload of 8 billion euros, or, like if you do the whole mission that we're going to invest $10 billion dollars and so forth. And so I remember taking a picture literally days before I was in the picture, and next to me was Stefan Israel, the CEO of Arianespace, and Daniel Neuenschwander, who actually grew up in Switzerland like me, but at that point ran space transportation. And we took a picture, and I showed that picture because we all looked so nervous because I made a stupid joke just before they took the picture. And I said, let's take that picture because all these jobs will become free if the rocket doesn't go well. So as we were there, I was tired, frankly, because I didn't sleep so well. I have a habit and have had a habit to basically practice in front of big decisions and big things, both speeches, the good and the bad one. That's a habit I took on. It's good to remember that not my entire life lies on that, and that gives you also a lightness of what's there. So I just remember being taping that speech actually, and frankly, then the next morning sitting there next to Josef Aschbacher on the one side, who was the European Space Agency director, and on the other side my web team, and just seeing the countdown going really, really smoothly. And then we ran outside and we saw the rocket lifting. For me, the culmination of all these streams and all the work of 10,000 plus people on that rocket slowly lifting off. And of course, kind of it went so well. The Europeans did such a good job. But the thing is, when I saw the telescope disappearing, by the way, the only reason we saw that image is because we had a problem before. We had a problem with the fairing, kind of the tip of the rocket didn't open the way it's supposed to 2 years before. And so we needed to fix that. We put the camera there just in case we collided with the fairing, and we wanted to make sure that we saw if it collided where, so we could mitigate it. But you see this amazing thing taking off, and the telescope all folded up, and then you saw the solar panels coming out. We did not expect to see the solar panel. The reason it came out is because the Europeans did such a beautiful tip off that it basically say, I don't need to correct. I just opened the solar panel autonomously. And I just remember looking around, and everybody around me was in tears because, it's almost like telescope waving back at the Earth. But most importantly, that was the goal of the day, to have a spacecraft with power. And of course, we knew there's a lot ahead, the whole unfolding, but what an amazing just final image, both, of course, seeing it finally with the rocket, but then seeing the telescope kind of with the Earth on the right side, beautifully floating away. And what we learned so perfectly, it added almost 10 years of lifetime to the overall telescope. It just was absolutely beautiful.
And that might even be underselling it. I've, originally was expected to last 10 years. Now it looks like we're going to get 20 years, maybe more. We'll see what happens. It's, I don't know. It's like, are you still waiting for the other shoe to drop? I mean, we got some micrometeorite damage. That was unexpected. But apart from that, cycle 3 was just approved. Mm-hmm. And the science is coming out just furiously with amazing discoveries being announced day after day after day. When will this stop?
Well, I think now it's a space mission, right? Kind of once we're on the other side of the deployment, once we're on the other side of the launch, right? Kind of, that was really unusual in this mission, by the way. But usually 80% of the kind of overall mission risk has to do with the launch and the initial setup, right? Kind of just once you're there, it's like it's 20%. We know how to handle it. Of course things happen, but you have ways to fix it. And in this case, the launch was only 20% or so of the risk, because the majority of the risk was in the deployment, which of course we'd never done at that complexity. Once we were on the other side of that, of course, there's never been a space mission that went exactly like planned. I mean, it just, so often we have the wrong, expectations. I remember kind of, journalists asking, oh, that's unexpected. Yeah, it's the micrometeorites. There's one that hit too early. It hit a year too early. Well, okay, so we actually, I mean, first of all, we know kind of much more now about the flux, kind of the monthly hits and so forth. So far, the second big one has not arrived, right? So kind of, statistics is really hard to predict based on one impact. But so yes, that's there. Of course, some of the sensors are aging a little bit faster than they should. Some of the European sensors, and also that is like, okay, stand in line. We've had that problem, right? Kind of. So how do we do that? What I've found interesting when we had the hit of the big telescope, we really changed the way we did the observing program in a way that we basically, if you want, moved butt first, like in the back of the spacecraft, there's just more robust first into the streams. And so, I mean, it's never over, right? It's a space mission. It's never over, but I know the team, and what they have really done, just especially during that deployment, but also from then on, just have done a wonderful job. And I'm talking about the international team, not just one part of it, both on the spacecraft side, but also the instrument side. I mean, I expect many, many years of amazing discoveries from this telescope.
And this was just one of the dozens of spacecraft that you were overseeing at NASA, as well as the dozens that you helped launch and deploy and oversee. And we don't have time, it would take all day for us to go through a lot of them. But can you give me some other stories of some missions that you sort of think fondly of or were nervous about? I'd love to hear some more stories.
I think for me, kind of emotionally, one of the biggest missions was actually a mission called Parker Solar Probe. So, frankly, what's good when you join an agency like NASA, you don't really know what the rules are that here are the things you should not do. As like I did not know that there are things like that. So I came up with the idea of naming the mission, which was called Solar Probe Plus, after Eugene Parker, a professor at the University of Chicago, who predicted that there's a supersonic solar wind emanating from the sun. He, by the way, wrote basically all of plasma astrophysics, which is a large part of the astrophysics community. He basically largely invented, together with a few colleagues, but he came up with the processes that create magnetic fields, dynamos, as they call it, turbulent, like many cosmic rays, many of the top things. But anyway, I did that. And I remember it's the only time I really got yelled at by a leader. And basically what we did is I said, look, let's name it after this guy. And for whatever reason, I got all signatures. I'm still surprised by that because this had no precedent. One should not name after people alive. He, of course, was 90 years old about when I named it after him. And, like we had checked, there was really no noise in the system relative to his behavior or otherwise. But my PR guy said, hey, this is not, you should just know this is not going to be a big story. And we're just, let's just do something. I said, that's fine. Let's just do something for him, for Eugene Parker, because me and many others have just really felt like, for example, I cannot understand why he doesn't have a Nobel Prize. It says a lot more about the Nobel Prize Committee than him. And so basically, I was there and we were renaming the mission. And I remember sitting there, in the front in the University of Chicago, and all of a sudden I noticed like 6 cameras in the back of the room. What the hell? That's not, local TV, international TV stations. And as I stood there, the phone started ringing and just like, it became a super story, like, a mission to touch the sun, with kind of explaining how that went. Of course, the mission was on development before. And so all of a sudden, like in the evening, my boss at this time, Robert Lightfoot, who is now at Lockheed Martin, kind of called me and said, what the hell are you doing? Everybody congratulates me about this mission. And why aren't you informing me? It's like, I did. I just thought it's going to be a small story. I didn't give you the briefing package because I thought nobody's going to ask. And of course, it went off the charts. It was one of the top stories. In the meantime, this mission has delivered on its promise, like exactly like we're hoping. And of course, there's going to be an eclipse on April, early April. And for me, the corona we're looking at, the atmosphere of the sun we're looking at we know a lot more than we knew before. We also know that in later in the year, in 24, Parker Solar Probe is going to go on its closest trajectory. And of course, as an American football guy, right, if one end zone is the Earth, the other is the sun, we go to the 4-yard line with that mission and kind of with its heat protection system. And for me, the reason it's so emotional is because of Eugene Parker, and especially having him there at launch. And I will never forget, he was there in tears, his entire family, as the rocket lifted with his name on it. And nobody had ever lived through that. And he was supposed to go to the TV camera, and I was sitting there, and he says, Thomas, come. He knew I was the guy who did it. It's like, he said, thank you so much, Thomas. That means a lot. And then he said, I wish these bastards were still here who tried to stop this theory, but they're all dead.
Right. That's how science works sometimes.
Yeah, but what's interesting is he never said anything on camera at all critical. But then after this amazing launch, he's like, I wish these bastards were here because I wish I could show them what happened with this. Because, of course, that, as I said, nobody had ever lived through this. So that's a very emotional mission. For me, it was so emotional because I was actually part early on of defining that mission as part of a science definition team. And kind of seeing that mission, which is so hard, come to flight. What many people don't know, within the cost exactly that they were predicting. I mean, it's a super success in all dimensions and just super mission. Of course, I could go on and on. Many others. If you ask me for the next one, it probably will be Perseverance.
I mean, there's a paper that or a story we're working on about a paper that just came out saying that Parker Solar Probe has made in situ measurements of, and I forget the number, but I feel like it's dozens of coronal mass ejections from 2018 to 2022. And you just like, oh, interesting. And then you're like, wait a minute. So the spacecraft flew through dozens of coronal mass ejections, which no other spacecraft has ever really done to this extent, took them face on and was making measurements of what's in a coronal mass ejection for really the first time. And not only it's done it more than a dozen times, and we're going to have a completely different understanding of the way the sun works thanks to that mission. Not to mention all the others. No, and I know your time is precious. We could literally do this all day, so I would like to instead talk about a mission that is sort of still in the works. What is, right now, the Decadal Survey wrapped up its most recent meeting, made a bunch of recommendations about the Habitable Worlds Observatory, about maybe a mission to Enceladus. There are some other sort of requirements. So, like, what is the one that got away? What is a mission that you thought, oh, this is terrific. I really like this idea. This really solves a lot of problems, but maybe it hasn't come to fruition yet or is still sort of in the future?
So I wanted to know, kind of as the head of science at NASA, whether it's me or Nikki Fox, who is there now, or John Grunsfeld, who was ahead of me. I really don't consider it the job of the head of science to decide what the missions are, generally speaking. There's a very few exceptions where I think that's applicable. What we should do is follow the science consensus. And I think what that does, it creates very much more stability in science than in many other disciplines. I think that's why within NASA, science has been so incredibly successful. So if you ask me what's the mission that got away, right? I really, and there's one that's kind of hanging in limbo a little bit, which is, of course, Mars sample return, which is in part there, but just because the team struggled more with getting it there. Perhaps, of course, kind of you stand down from your job. You basically say, "What the hell did I miss?" And what's really important, and what I've started to do is kind of when I see mistakes that I made, is to write down mistakes I made, so without doubt, I have some responsibility of that also. But bringing samples back from Mars is certainly one that I would like to see. I mean, I'm right now sitting in a university which has labs, a building over that we would want to use to kind of look at both the isotopic composition, but also the chemical composition of these. For me, though, the mission always wanted to do it, always had a low-level recommendation, and we don't know what it's going to be before the decadal is out in heliophysics. I think we should really do a interstellar probe precursor. I think I would like this generation of humans to bring spacecraft to thousands of AU, 1,000 AU, Voyager, the generation ahead of us, the good people, Ed Stone, Tom Kermegis, the engineers and managers, Tom Gavin, all these people who got Voyager to, observe all these outer planets, but then basically moved it, over 100 times the Sun-Earth distance away through the boundary of the heliosphere. I would really like to go 10 times farther. And because what that would set up the next generation is to actually ideally to go perhaps one more step, but ideally go to the next stars. I think we should, in fact, go to the next star, and we have not done that.
I mean, there are some really interesting mission concepts for going out to that kind of distance. I mean, you mentioned the interstellar, just sampling the interstellar environment would be great. There's the solar gravitational lens, which would be, probably the most powerful way that we could observe distant objects, and what the outer reaches of the Kuiper belt, maybe the inner limits of the Oort cloud, maybe trying to find, there's so much out there. I agree with you. So I've been reporting on this stuff for 25 years. And what I see is, while there's a lot of amazing missions that are done, often there's a reticence to use some of the newer technologies. It took a long time for, say, ion engines to finally make their way into a mission, like with Deep Space One, and eventually it was part of other missions as well. What are some technologies that you think are very promising for either from an instrument perspective or from a propulsion that you think could have a big impact that maybe somebody needs to go first?
Yeah, I mean, if you look carefully, I mean, you see that during my time at NASA, I was really very much focusing on new technologies. That's why, in part, there's a helicopter. That's why, in part,
Yeah.
there is, and frankly, there would not be a chronograph on Roman, which there will be, because we basically said we're going to do it anyway as a tech demo. PACE, that is looking at the ocean colors, has two instruments on it that basically have the function of tech demos. We did, on top of a Landsat launch, we put Shell to basically demonstrate landing at Mars, that we landed at near Hawaii. So for me, I think it's absolutely important to kind of, yes, do a good job with your mission, but I think every mission should bring back into the toolbox of things we know how to do, into that toolbox, bring one thing back that basically makes the community better. And so for me, that's a philosophy I believe in. Like so often we put small satellites with it. When we did DART, deflecting an asteroid, of course, that itself was a tech demo, but we also dropped a small satellite on the side in deep space. And nobody had ever done that, kind of as a camera to look from the outside. Kind of my comment was, we will not go smack a spacecraft into an asteroid, not even try to image it. Like, I want to see how it looks. And I just saw a paper coming out in Nature that says those images are actually really important to constrain the surface composition and make. So there are some important technologies that are coming out. For me, kind of nuclear propulsion technologies, I think, are absolutely essential, especially if you want to explore the outer solar system. Also for long duration missions on the surface of the moon, even. I think nuclear technology is really critical. I'm glad we're starting that. For me, it has not come early enough. I believe there's new technologies kind of in the quantum realm that have tremendous potential, especially atom interferometry, kind of using quantum technology to measure gravitational fields, or even at very high level by looking at entangled atoms or objects, could be membranes, and really looking at them kind of on a single spacecraft. It has important consequences for the Earth. And there's other kind of, that whole quantum realm, I think, is breaking out. And I really think kind of on a timescale of 5 years, we should, try these things and move them forward. I believe that as a third, of course, we could also here go forever, but as a third element, I just think the way we use computing really has to change. Generally speaking, the way a system design works of a mission in a traditional fashion, kind of in many ways, you figure out what are the data you need to the ground. So kind of how many megabits per second or gigabits per second, depending on whether you're near Earth or somewhere far, go to ground. So then you build the instruments and feed that stream, and together with health data from the spacecraft. But imagine if we had a mission that has 1,000 times the data that you can bring down, and instead of bringing everything down and you can crank through a computer, find important data, you do that in space. Imagine how more powerful this could be. Especially, you could even imagine having computational centers in space that you connect through much closer kind of communication tracks, and really, in fact, change the whole equation. The one mission that is making a leap in that direction is the NISA mission between India and the US that is launching later this year. It's a two frequency kind of radar type of mission looking at the Earth. It itself is almost doubling the data output of Earth science missions that are out there. And for me, that's what we should be doing. If we start thinking hyperspectral, I want these data up there and just really flipping the system design and making these more powerful computers to be part of systems. We don't have these computers right now because we're trying to make them more resilient to space radiation, and we use kind of very old technology. For me, it's like, how do we flip it? The entire computation, especially in the presence of AI, how do we flip that whole thing? I think that the realm just really is opening in front of us for a lot of breakthrough research that we just haven't been able to do.
Yeah, I have definitely reported on that. There are some interesting missions like large scale space interferometers, like the Event Horizon Telescope, but in space, or an Event Horizon Telescope that is the size of Earth's orbit. But then you're limited by the bandwidth. And so then if you could push that computing onto the mission, suddenly you're no longer limited. And now so there's missions that would make sense again. It's an interesting direction to go. I want to talk about the international level of space exploration that's starting to happen. I mean, I think for most of the time that I've been reporting, it has been NASA, with some ESA. And now we're reporting on stuff that's happening from the Japanese Space Agency, from the Korean Space Agency. India is just making amazing gains in what they're doing. The United Arab Emirates. It goes on and on and on. What has sort of driven this shift of space exploration to be a more international affair?
Look, I mean, I think
China,
China
yeah.
especially, yeah.
Yeah.
But look, I mean, I think in general, what's happening are two forces that move us in that direction. The third force has always been there, which is there's pride of nations to be involved in space. And if you don't understand that, you should watch again the Israel kind of broadcast of the landing on the surface of the moon. I just want you to, I want to quickly stop on that. I want to quickly stop on that for one reason, which is this is the second time. The first time did not work. The first time the president there, I don't have any political preference whatsoever. Let's just talk about the leader. He sat in the room and it did not work. And the person who was in charge of the mission broke out in tears. The president walked over, hugged him and said, thanks for getting us that far. Let's try one more time. So here's the second time they land. And of course, he is not in town, but camera on his face as they're landing. And basically the camera goes back and forth between his face, the president, and the team. And I want to tell you, I've never managed to get a US politician on camera during anything difficult. They always come after the fact because they don't want the camera on their face doing a risky thing. They don't want to be in the room with something that's not going well. Well, he did. And then, of course, it did so perfectly that, you see, I was on Indian TV at night, multiple stations, right? Kind of just congratulating the team because, of course, I know him. I saw the spacecraft in the room in India, and they're doing it differently than the US. I want you to know, very differently. But what a success. The same with Japan doing these things. So you have that pride, is my point. You have the pride. But there are two forces that are really important, I think. The first one is frankly, an economic pull. Many countries have the sense that space will, and of course already is, but will be much more related to economic power than it is today. That's why many countries are supporting actively startups. India, for example, very actively. Despite the cultural challenges, Japan also, right? There's a lot of stories about Japan and failing in business, kind of what happens there, right? None of the stories are really good, but even Japan is really actively focused on and has amazing companies doing that because in JAXA is supporting whatever they can, right? On the side, really encouraging that. I really saw that. So you see the economic thing. And then the second one is frankly the political power struggle. Part of it is East-West. I've never been in a meeting of some of the countries we just talked about in which China wasn't mentioned. I'll just leave it there, right? The other thing also is just really, hey, how are these kind of activities how is space being used to make people safe in their own countries and kind of be able to push back? So it's those two forces together with that patriotism that is motivating. I think that has really opened up many doors because frankly, what we've learned is there are ways to do things cheaper. And, look at how much India took for their lander. I mean, it's a fraction. It's about 10% of what it would take the US. Now, in the US, we count the salaries also. India, perhaps differently. I don't know. But kind of the point is, it's It's good. It's really good. So I think there's an amazing, basically every country. I mean, I'm sitting right now as I'm speaking to you in Switzerland, right? There's a national discussion here. What should we do in space? And kind of both as part of the European Space Agency, but also as a country that really has aspirations and technology capabilities.
I mean, we think about, say, how the International Space Station became this collaboration between the United States and Russia. And obviously things have gone south since then. But I think there was a lot of hope that by enemies collaborating on these kinds of projects could sort of lead to greater peace. Do you see these kinds of collaborations forming? I know, like, even with China, foreign researchers can use the FAST telescope. They're planning on bringing an international taikonaut on board at some point in the near future. Their plans for the moon are going to involve multiple nations. They're inviting various nations. Do you see things moving towards collaboration or more towards people going their own way?
My hope really is that we're moving more towards collaboration. I just think, like, if you really want to go to Mars, I actually think it will make a much better story if we went together as a planet, not just one side of it. I think right now, because of the defense and kind of national security side, there's quite a trend in the other direction. But I just wanted to know, kind of in my time at NASA, there have been a number of steps that I consider very positive of types of collaboration. For example, and they made it public, so I can talk about it. But when they landed on the far side of the moon, they told in a meeting, we had a meeting, because frankly, what we don't ever want to do is smack spacecraft into each other on a planetary body. That's just not smart for anybody. So it's how do we exchange as you're going to the moon? Like, we're already there with a spacecraft and so forth. How do we do that? So I remember in the meeting, basically, we said, let's exchange orbits. But I basically said, why don't you tell us when you land and the location? And why don't you make the data public? Because that is really the standard we would like, because that's the maximum science we can get. People find data back and forth. And I remember the first answer was the location and time is a national secret. And but I will see what I can do, he said. And through an interpreter. And what happened is before they landed, I had an email with the location and the time. This is where we're going to go. Now, sadly, we could not rejigger the LRO because LRO is actually kind of, lunar reconnaissance orbiter, even though it's the most successful lunar spacecraft ever in terms of publication output. It's kind of an old person equivalent of a spacecraft. It's not exactly youthful exuberance. So we couldn't rejigger it to go there for power reasons. But what I wanted to see, like the reason we asked for it, by the way, it's not because of, we wanted to see during the landing at Bloom, is there water released when we land? And so the answer is I could not do it because of our spacecraft, but not because of the Chinese. They told us, they also, frankly, I'm sure not because of me or anything like that, but they made a lot of their data public. And so for me, that's good. Also, when we, at Mars, when they achieved that feat that only two nations achieved so far, which is softly landing on Mars. They're one. The US, of course, did it a number of times. Also, then we exchanged orbits. And so for me, I just really believe even though we, in some domains, we're not on the same page and that's what's going to be. I think science can be one of those domains where it's in the national interest to kind of have a dialogue. Just the way we had during the Cold War, where certain things were possible and we made possible. Of course, we don't want to be, not all possibilities are open for that dialogue, but I think, for example, kind of an agreement in which we really all make Earth observing data public could be in the interest of China, the US, Europe, Japan, and everybody. Right now, Chinese data are not really generally open. And and frankly, in some case, kind of are disturbing the market, the commercial market that we're both setting up. So I think there is hope based on my experiences that can happen. But of course, even though the story sometimes is told like peace comes from space down, it starts on the Earth, right? Kind of with people saying, let's try that, right? Kind of, even though we have, during the Cold War, massive disagreements with the Soviets, let's try it because it's better for us. It's better for humanity. It's better for our own country. And I hope there's discussions like that will happen with China, because I just really don't see, frankly, why it cannot. But again, that's above my pay grade generally.
Yeah. No, but I mean, like, my perception of this as a journalist is I'm so accustomed to NASA and ESA having all of the data available, and I can just dig through it as far as I want, and we can report on whatever aspect of the story is interesting to us. But when stuff is coming out of China, we're limited, and nobody answers my emails. And that's to their detriment, I think. Like, if their objective is they want to be recognized and appreciated on the world stage for being excellent in space exploration, one of the ways that they do that is by building public relations, by us reporting with excitement on the projects that are happening. And if we can't get access to the pictures, to the data, to all of that, then we can't report on it. And then we're just going to cover something else because it's just not worth our time. And so I think if this is a direction that they want to go, they have to be more open. And that's the lesson. I mean, NASA figured this out a long time ago. ESA figured this out a long time ago, that this is the way you build an international reputation. And
I really want to give credit to those who were ahead of me at NASA, because that changed kind of when I was a young postdoc coming to the US. All of a sudden, a requirement came that, in the late 90s, the data needed to be public. And there was a big unhappiness, especially of all the kings and queens that were masters of their instruments, right? Because all of a sudden somebody said, rip it away. It's not there. I remember there was a time I was really worrying about my job, because the person who was in charge of the instrument, I made data public like I was supposed to from NASA. And all of a sudden, kind of my job became a little bit wobbly, because I was undercutting his career goals, right? And then, of course, my personal mentor and boss, Len Fisk, who, of course, was a former NASA head of science, protected my job then. But how the transformative that was for the entire series of instruments was just could not be overstated. We went from almost nobody looking at the instruments for that data to be the third most downloaded data of the entire mission, that particular one. It became, there's things people figured out how to use that data we would have never figured out. They were in Nature and Science. It was fundamentally new observations. I mean, fundamentally new interpretations of the data with the same observations. So I'm such a champion for open data because there's more science. I'm also a champion because, frankly, one of the things I worry about is we want to be sure that our science is verifiable. And not just kind of at the minimum level. Oh, I'll just give you the data that I pulled back. It's like, how did you actually get from the data kind of as close to raw to that conclusion, especially if it's at the noise level? And there is a lot we can gain from that. And frankly, that's why when I was at NASA, and of course, in support of the entire team, we actually made it even more open, in a sense that actually algorithms that use the analysis are also to be made public, because I think that at the end, what makes science powerful is the trust. And kind of for me, it will help all of us if it was, I think the standard in big journals should be such that data should be public for these things. And frankly, we should not allow kind of papers in which kind of it's not verifiable at all, because it's kind of based on a unique data set that nobody else can go there, right? I mean, I've always worried about Voyager. Like for a while, we had worry kind of the biggest cultural clashes were on Voyager because kind of every year the PI group became a year older. By the way, amazing scientists. They're just the game changed, the culture changed. And I was so glad when Nikki Fox, who's now the head of science, when she was in heliophysics, she really made sure that data became public because it will take a while until we're there and basically make these measurements again.
So previously, you were the head of science at NASA. You have a new job at ETH Zurich Space. What's your new job?
Yeah, so I basically have more than one job, which is what happens when you kind of searching. I have a part-time job here at ETH. As you know, ETH is the leading university in continental Europe by most rankings. And, so it's a good technical university. What's interesting is even though they're really, really good at many things, they have actually not been as present in space as they should be. And they know that. And so they asked me, hey, could you come help us build that program? So what I'm doing is what I think every university should do today that wants to play in that. I'm focusing on an educational program and very much focused immediately on the new type of educational program, especially also commercial space, not just, a given agent. Many people, if they go to ESA, that's wonderful. Go to NASA, that's wonderful. But we also want them to start companies and kind of do some of these things. I'm really proud that many of my former University of Michigan students are doing that right now. The second thing we're doing is building a kind of an accelerator for ideas out of the faculty and really making sure that, like we said, quantum technology gets to space. Why aren't we the first ones to do that? We have an amazing robotics program here. So one of my team members right now is in Houston looking at, meeting with Intuitive Machines and some of the other CLIPS providers, because what's really cool with these companies that are now able to go to the moon is international partners can use those, just like people sent their astronauts to the space station using a commercial company. So again, what is the research that can do it? And the third one is very much focused on the entrepreneurial side. We're talking right now to about 60 startups kind of in and around Switzerland, and kind of the question is, how do we create the funding vehicle? So I'm doing that just to, in some ways, also to give back, because of course I'm a product of public education in Switzerland. In parallel to that, I consult. I also give some speeches here and there, and I'm trying to figure out where is the one problem I can bite in, where I can really make an impact further, and kind of really kind of something that, like I always work, is fully focused on one thing totally.
Yeah, it's a tricky problem, especially when I think about entrepreneurialism in space. I mean, there is just a trail of shattered companies who tried to get into space mining or whatever, that it's really hard to make a profit out of space when the risks are so enormous. And yet, if we want to have that solar system spanning civilization, we have to crack this problem. I don't know what the solution is. Good luck.
Yeah. I don't know either, but I think we also have companies that are successful. We have companies that are transforming the way we're looking at space. And of course, it's easy to think about SpaceX, and I think it's an incredible company, but look at Rocket Lab. Look at, as we just said, Intuitive Machine. Look at Planet Labs, like Earth Observing. Look at Spire. Look at others. I think what I'm really also seeing, though, is very much a market for downstream companies. I think really taking, especially in the presence of AI and other kind of data technologies that are really accelerating, like how do we actually make data useful and for people here? It may not be $1 billion company, but I think, like if I looked at kind of how do we help farmers, there's a data study I just saw kind of in Central Europe where somebody basically took over a field and basically told the farmer, got the deal with the farmers, like, why don't I tell you what to do here based on information I have from, say, it's not like my grandpa told me or my dad. And he basically managed to get half of the nutrients and water into the field and 30% more, the more products from the field, because you did not overwater it or put too much fertilizer in it, right? Because it's not good for any kind of, whenever you can do win-wins. I mean, the example that comes to mind also for me is when we were putting Emmett up, a mission on the space station. It was there to look at kind of the minerals of dust that, of course, become aerosol. Within weeks, the team found these methane leaks. Like, a methane leak is just stupid. It's hurting the atmosphere, and the people who are losing the methane out the top are losing money. It's in nobody's interest. So people started calling up, like, hey, you have a leak. It's like, thank you so much, right? And so for me, it's like, these companies, and of course, MethaneSat just got launched, privately funded, satellite, which is, really amazing. For me, it's also looking at these plays, right? Kind of, how do we kind of create win-wins in which, we really help better decision making on Earth as we go.
Thomas, what are you obsessed with?
I'm obsessed with two questions that I can't get out of my head. The first one is really how to find life in the universe. I mean, for me, it's an all-in kind of problem. It's kind of, in many ways, many of the questions organize around that question. Habitable Worlds Observatory, I know you talked about it before, but also whether it's Mars sample return, some of the moons. And frankly, for me, it's just like, as a society, it's just, perhaps the Europeans go to this target, the Americans go to that. And of course, Clipper is going to launch later on, is moving in that direction. I think that this is kind of tip of the iceberg, kind of really understanding and detecting kind of the transition from a physical chemical world to a biological world is super exciting. I think the second one, I really hope we could make progress is visiting another planet outside of another star, kind of moving in that direction. I don't think our generation will figure out how to do that. But God, we need to make progress. I mean, what is our cathedral kind of that we bring to the next generations? And everybody says, that was cool what they did. They came together and did something magnificent. For me, those are the two questions of that ilk.
Is there a mission concept that you find exciting, or is it just such science fiction still?
Well, I think the first goal should be that really go about 2000 AU in 20 years, something like that. And I think the mission concept that are there use near solar flybys and perhaps some nuclear propulsion, or a combination of one or the other, or a combination of the two. There's a concept also of a solar sail, a big solar sail that's going by the sun and basically using radiation pressure to go out. That's a lower payload in terms of mass and power. But so there's like two or three mission concepts. Now the question just really is, what is the right one to actually make a significant dent? We don't want to do a factor of two. That's just not interesting, in my opinion, because the motivation should really be to kind of chart in there. So yes, there's good ideas. I think there's a number of the propulsion technologies that are in people's minds and labs, but are not in space yet. And some of them should be used and should be proven. And, so if you said, hey, let's go in 15 years, right? For 5 years, let's put these technologies out there and try to figure out what we could do. I think it could be a massive kind of leap. I just think we want to go visit other stars eventually. Initially with our robotic emissaries, and then later on, hopefully we'll figure out a shortcut, or, hopefully there are these wormholes that everybody's talking about, right? From the theoretical physicists all the way to the sci-fi authors. So I hope we find a way to go there. I mean, that's what I'm dreaming about at night.
Yeah, it's funny. People ask me, like, why would we bother? Like, Earth is the best. Why would we want to go send spacecraft to other star systems? And I was like, well, if you could go to a website where you could click from star to star and see actual pictures of the actual planets around that star and see the dramatic features, the size of volcanoes, the depth of chasms, the interesting landscapes, the weird things that the universe got up to, and maybe the life forms, and maybe the cities, and maybe all of that. Like, would you want to browse? Would you want to go to that website? And yes, okay, great. You're curious. unfortunately, we don't have that website. So the next best thing is we're going to have to build it. And that's going to require all the complicated work of building spacecraft to go to other star systems. It's not
Yeah,
going to
and
be easy, but
Mhm.
imagine.
I agree. I think there are two things that happen when we do one of those leaps, right? So we go to a place. So we're moving the boundary of ignorance. Like that website does not exist. We want to fill it, right? Kind of because we want to teach it in every school. Like, hey, there's other worlds, right? What it also does is also important, and that is it changes our boundary of thinking. Like the way we see ourselves, the way we think about what's possible and what's not possible is changing too. And we need a lot of things to move in the realm of possibility now. I mean, I'm a, if there's anything that happened to me in my years at NASA and kind of in things I've done in my life is I'm become more optimistic because I've seen what teams can do. I've seen some of the inner bowels of bureaucracy that I never want to think about. But I've seen the beauty of teams that tackle important problems and can do it. And God, we need those right now. I don't know whether you've observed some of the temperature measurements of the ocean since April last year, right? I mean, there is no climate model right now that predicts what we're observing. And I'm 100% sure the observations are right. Two of the measurements come from space and satellites that I understand really well. And the third one, of course, buoys that are right there and they're very much consistent. So for me, we have a number of things on Earth right now that are happening that we don't understand. So we need people who kind of reach and take from the things that are not possible and make things possible. Kind of a way to look at climate changes. We need 12 massive companies, not 200. Solving big problems. How do we replace concrete? It's kind of like big problems. And so for me, that's the same kind of type problem, going to another star. It's that attitude that it's like, it's really, really hard. Well, damn it, we'll do it because it's hard. And that's has been always our mantra. And it needs to be that in the private sector, but also in the government side of the house.
And it's funny, like for me, those kinds of challenges, I find thrilling. I find them exciting to solve. And when I talk to people who are solving them, and when you hear the practical ideas that they've come up for this kind of stuff, I think it's just amazing. And I love that idea, even of increasing your capabilities of what you can accomplish, be it from existing missions or even just from what we can do down here on Earth, that we build more options into the future for what is possible. And this challenge of decreasing our greenhouse gases, the challenge of exploring space, I mean, they're all tied together. And it should, hopefully, people should feel inspired and excited to take on these problems, not overwhelmed and not cynical and not, I don't know. It's funny to me to sort of see the discourse when I'm just like, all I want to do is just start solving problems if I can.
Yeah.
And cheer on the people who are.
Yeah, exactly. I'm the same way. And clearly you've done that in stride. So I just, for me, it has to do with a little word, only for a little word, which is hope. Like, if you take something like that on, the only people who actually act are the ones that have hope. Like, yes, it's super hard. And, I remember taking on James Webb Space Telescope, massive problems, almost 2 years we were standing still. The question is there any hope? And what I believe is just that hope is a choice. It's not data, it's a choice. And then a choice you make every day. Am I hopeful today? Am I driving towards these solutions? And kind of come from the point of view is like, it is possible to make a dent in the universe, kind of in a good way, whether it's in exploration or it's helping society or everything in between. So for me, that's also something I think we learn in space exploration and we resonate with so much.
Thomas, thank you so much for your time today, and good luck with figuring out that next big project to sink your teeth into.
Thank you so much. I really appreciate what you do. Thanks.
I hope you enjoyed that conversation with Thomas Zurbuchen. I sure did. It could have been 3 times as long. He had limited time, so I had to sort of time everything perfectly, but I hope we can talk again in the future as he has new projects that he's working on. Now, before I give you my thoughts about this, I want to thank my patrons. Thanks to Abe Kingston, Andrew M. Gross, Antonio Lofilar, David Gildenan, Dougie Stewart, Dustin Cable, Jeremy Mattern, Jordan Young, Josh Schultz, Mark Anstis, Paul Rohrbach, Stephen Krasaki, Stephen Feiler-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. There was one concept there during that conversation that really resonated with me, and this is idea of introducing technical risk, new ideas deliberately into your projects that maybe nobody wanted, that are only going to increase the risk and complexity of the mission, and yet they're going to provide future learning that and technological advancement that will benefit future projects. The price you pay is that you increase the risk of the project. That, yeah, we're going to add a solar sail to this project, and it's going to attempt to deploy the solar sail, and we don't need the solar sail, but maybe we could use it to shift to a new target or whatever. And people are going to be like, why are you going to add this risk to our project? We just want to get the science. Well, because an additional part of the science is thinking about the future. And I really think that NASA's role and all of these space agencies' roles is to live right at that cutting edge where they are attempting to help the world remove risk from the future of space exploration, of astronomy, of technology, of aeronautics, of Earth observation, that there are great ideas, but they are just not commercially viable. And that you can have these agencies step in at this perfect spot and go, here's this idea. We know that it can be developed. Here's a chance for us to try this out. It could have an impact on the mission, but it might have an incredible success. We'll learn a ton, and then future missions can just include this by default, like helicopters on Mars. You know, I can't imagine a mission going to Mars from here on out that doesn't include a helicopter because they're so successful. So hopefully we will see that same spirit carry on, not only at NASA, but also at ESA and also other space agencies into the future. All right, I've done, as I said, interviews with other people behind the scenes with the James Webb Space Telescope. And so I'm going to leave some links to those here if you want to watch those. All right, thank you. We'll see you next time.